Hi everyone, welcome to lesson 9 of the Advanced Higher Stats course. In this lesson, we will be looking at the continuous uniform distribution. You will find this skill on page 22 of the Advanced Higher course spec. By the end of this lesson, you should know what a continuous uniform distribution is. You should know the differences between it and a discrete uniform distribution. You should be able to write the parameters of the continuous uniform distribution. You should be able to calculate the mean, variance, and calculate probabilities using a continuous uniform distribution. So what is a continuous uniform distribution? It's a probability distribution for a continuous random variable where every outcome is equally likely. So this distribution deals with intervals rather than finite set values. So like when a bus is said to come between 1 and 2 p.m., it can come any time between that range. So that would be shown as a continuous uniform distribution. So what are differences between these two uniform distributions? For the continuous uniform distribution, it deals with a continuous random variable and deals with intervals. But a discrete uniform distribution deals with a finite set of values and deals with a random discrete variable. So an example of a discrete uniform distribution would be a dice roll right here. Because you have a finite set of outcomes, the roll can either be 1, 2, 3, 4, 5, 6. It can't be 5.5, it can't be 4.2, it can't be 2.1. But for this continuous uniform distribution, if the range is 1 to 3, it can be 1.1, it can be 1.01, it can be 1.001. In this uniform distribution, how would you find the mean, variance, and probability density function? You need the limits a and b, and what they are basically a is the lowest possible value you can get, and b is the highest possible value you can get. So in the graph, b would be number 3, and a would be number 1. Now let's try the following question. Jacob is waiting for a bus that comes between 3 and 4 p.m. Write the parameters and find the expected time the bus will arrive and its variance. So the first thing we should do is we should find the limits. So a, the lower limit, is 3, and b, the upper limit, is 4. So how we would write the parameters is a uniform a and b, so 3 and 4. Next up is finding mu, or the mean, which is a plus b, so 3 p.m. plus 4 p.m. over 2, which gives us 3:30 p.m. Next thing we need to find is the variance, which is b minus a squared over 12, which is 4 minus 3 squared over 12, which is equal to 1 over 12. And then we times that by 60 to get a time. And that gives us 5 minutes. And find probabilities using a continuous uniform distribution. In this question, the continuous uniform distribution has an interval of 12 and 31, and we have to find a probability of x being less than 23. What I like to do first is draw the distribution. So something like 12 and 31, so something like this. Now, first thing we need to do is we find this y value here, and this y value is the same as the probability density function. So how we'd find that is 1 over b minus a. So b is the higher number, which is 31. A is the lower number, which is 12. So that means 1 over that is 1 over 19. So now we know that the area of all of this is 1 over 19 times 19, which is 1. So if we want the probability of it being less than 23, we need to find the probability of this section here. So the range between 12 and 23 is 11. So we would just do 1 over 19 times 11, which gives us 0.5789. So the probability of x being less than 23 is 0.5789. Now, for the next one is the probability of x being greater than 15. Now, it's kind of the same thing here. If we just erase this and now put 15 here, and we want to calculate this area here. So the difference between 15 and 31 is 16. So we do 1 over 19 times 16, which gives us 0.8421. The answer to this is 0.8421. Now let's try a similar style question, but we are using time now, so we have to be a bit careful here. Jacob is waiting for a bus that comes between 3 p.m. and 4 p.m. Find the probability of the bus coming at or before 3:25. So how I would like to tackle this is by, instead of doing 3 p.m., 4 p.m., I'll do 0 minutes weighted and 60 minutes weighted. And the difference between that is 1 over 60. And that means I'm trying to find the probability of x being less than or equal to 25. So if I put 25 here and I want it to be less than, I'm looking for this range. So that means 1 over 60 times 25 is what I'm need to calculate here. And that would give me 0.4167. And another thing to note is that because we're using a continuous random variable, the probability of x being less than or equal to 25 is the same as the probability of x being less than 25. Because in continuous distributions in this uniform and in normal, the probability of x being a exact number like 20 is so small that we call it 0 in advanced higher anyway. End of the lesson. Now you should know what a continuous uniform distribution is. You should understand the differences between the two types of uniform distributions. You should be able to write the parameters, calculate the mean and variance, and calculate the probabilities using a continuous uniform distribution.